So number 4 on this is June 2022. Number 4, in a group of 40 people, 20 have brown hair, 22 have blue eyes, and 15 have both brown and blue eyes. How many people have neither brown nor blue? Now this was tricky. How did you guys do this?
I started adding and subtracting and
You could. So if I am asked for neither brown nor blue, we have people that have brown hair, we have people that have blue eyes, but we also have people that have both brown and blue eyes, right?
What?
Brown hair and blue eyes.
Oh,
Brown and blue. Yeah, they're no. Brown hair and blue eyes. So the best way to do this, what I did was I found the complement. Okay? I found the number of people that have brown hair or blue eyes. So the probability of brown or blue, and do we remember the formula for this? Or.
It's like you add it and then you subtract.
Yes. You add the individual probabilities.
Like the together.
Oh, but it's not, yeah. You add the individual probabilities and then you subtract the intersection.
Yeah.
Now, I believe that this is all talking about number of people, so we don't even need to do probability here. It's just number. So the number that have brown hair is 20. The number that have blue eyes is 22. And how many have both? 15. So we have 20 plus 22 minus 15. What number is that? 27. So 27 people have brown or blue, but we're looking for the ones that have neither. So what we do is we take the total, which how many total people are there? 40, and we subtract the people that have brown or blue. What is 40 minus 27? 13. 13 have neither brown hair nor blue eyes. It's hard. That one was tricky.
Sorry, she just you got the key to my heart. Oh wow, that's cool.
So that was number 4. Now let's look at 7. Oh, this one. I've also had to do this one now in 2 classes. So there are 2 ways to do this. We could either do this in our calculator by plugging in Y1 and Y2. So we plug in 5E. E is the division symbol, second division. Raised to the power of x plus 2. And then in Y2 we put 7. And then what are we looking for? Let me turn off stat plot. Yes, you're right, McKenna. So my window's screwed up, so I like to do zoom 6 first. Oh, and I can see it. How do I find that intersection point? Second trace 5. Enter, enter, enter. Stop, Siri. Stop. So our intersection,
after you tell her to stop.
I know it. So our intersection, it says has a negative 1.66 number. I need to figure out which one of these is the same as negative 1.66. So I just do negative 2 plus ln is below the log 7/5. Oh my gosh. I'm pretty sure it's that one, but let's go through and check each one. The ln of 7 divided by the natural log of 5 minus 2. That's not it. Negative 3 divided by 5. Stop. Oh my gosh. Negative 0.6. That's not it. Negative 2 plus the natural log of 2. That's not it. So it for sure was that number 1. That's all you had to do. You found the correct intersection.
Problem sets are quiz grades.
Yes. So 15 points for a quiz grade. Also, we could have done this algebraically. How do I go about solving for x? What's my first step? First, I must get my exponential term by itself, so I divide by 5. How do I undo an exponential term? Opposite operation of exponential is log. E has a very special log that is its inverse. ln. We take the natural log on both sides. ln of e is 1. It cancels. We know one of the properties of logs was that the exponent can be written as the coefficient on the log. So this x plus 2 actually goes out of the exponent, and that left side is just x plus 2. What's our final step? Subtract 2 over. So we have x equals the natural log of 7/5 minus 2, which is in fact the same as that number 1. They're just flip-flopped. Okay, so that was number 7. Now 8. Oh, 8. Ugh, okay. I'm tempted to not show you this trick because I'm worried if I show you the trick, then you won't bother to learn how to do it algebraically, and this type of problem might show up on free response. In fact, it hasn't been on a couple of the free responses lately, so that means it's even more likely that it's going to show up on free response. Right. So I was going to show you the matrix way that we could do this if it showed up on multiple choice. If it shows up on free response, this is what we would have had to show. We had to get one of the variables to cancel out. So on that first step there, it's really easy to get x to cancel. I just add equation 1 plus equation 2, and x cancels.
I thought you went through and solved for y and then you took that.
So that's the substitution method. I taught you guys elimination because I think in general elimination works better. It gets a little too messy with substitution. Elimination, I'm just trying to eliminate variables. So I eliminate x, then I'm trying to, with another set of equations, get x to eliminate again. So I chose 1 and 3 by multiplying 1 by negative 2. And then x will cancel, leaving me with y and z. Then I take the two new equations, and I'm trying to get one more variable to cancel. If I notice that if I multiply equation 4 by negative 3, the z's will cancel. So that's what I did. I multiplied equation 4 by negative 3, and then negative 3z plus 3z cancels, leave me with just y. And then I solve for y. From there, it's just substitution. I go back and I plug y back into one of these equations, and I get z is 0. And that's all I needed for multiple choice because there's only one answer that has negative 1 for y and 0 for z. Or, if this shows up on multiple choice, you can just plug each one of these in to each one of our equations. But if I am doing it that way, I need to check all three. So I can plug in x, y, z. You need to plug it into equation 1, see if it equals 1. Then plug it into equation 2, see if it equals 0. Then plug it into equation 3, see if it equals 10. If it works for all three, then it's our answer. Or the final method is by using what is called a matrix. What you do is you take the coefficients on each one of the variables and put them into a 3 by 3 matrix. So I'm just rewriting the coefficients in a matrix here. Now the way that we get a matrix on our calculators is by hitting alpha zoom. Now it's a 3 row by 3 column. I'll probably do a whole separate video solving this problem algebraically and also using a matrix. So then you can go back and watch it. You have to raise this matrix to the power of -1 and then multiply it by the solution matrix, the constant matrix.
Wait, why -1?
It's just how you do it. I could give you an explanation, but you don't need to know it.
Okay.
So times Alpha zoom. Now this is a 1 column by 3 row. And boom, it gives you the answer. X is 3, Y is -1, and Z is 0.
Or is it 4, 6?